Hey y'all, welcome back to the Burma Nation here. We're working on lesson 9.4. 9.4 is all about this process called completing the square. So what we are going to do is show you that process. It's just another one of our techniques to solve quadratic equations. And it's going to be kind of cool. Each of the steps that we talk about are not difficult within themselves, but when you combine them all together, sometimes it's difficult to keep track of everything. So take your time, write things down, and check this out. So this method of completing the square is what it's called. I got to turn this on again, okay? Is to find the missing piece to have a perfect square trinomial. So we're going to want to make sure that we have our x to the second plus bx by itself. And our job is going to be to find the b divided by 2. We're going to square that answer, and then we're going to add that number to the end of the equation. So we're going to end up having an equation that looks like x to the second plus whatever bx is plus c. And we're trying to find c by using these steps. So that's what we're trying to look for. So here's our first example. We're going to find c in the equation that we just wrote down. So we have b is a negative 12. So in step number 1, I'm going to have a negative 12 divided by 2, which is equal to a negative 6. In step number 2, I'm going to take that negative 6 and square it, which is equal to a 36. And in step number 3, I find out that I'm going to plug that number back in for c. So c is equal to 36, and that is all we have to find because it says to find c. So I would be able to rewrite this answer up here with a plus 36 in there to have my perfect square trinomial. Now the whole point of this is so that we have a perfect square trinomial here. If you recall, that means that we're going to be able to just take the square root of the first number to get x, our a, take a square root of the last term, which is going to be 6, and then the middle term tells us if we're going to have a plus or a minus, and we are trying to get the factored form so we can solve our next steps. So that's what we're trying to get to with this mini step here. All right, so we're going to move on and use what we just talked about there. Example 2. We need to isolate our x to the second plus 6x, so we need to remove that plus 5. So we're going to subtract 5 from both sides. When we do that, we get an x squared plus 6x's plus whatever this open c spot is going to be is equal to 7. Now what we are going to do is just like what we did on the previous problem. We're going to have step 1, which is to take b and divide it by 2, and then we're going to square that answer. So 6 divided by 2 is 3, 3 to the second power is 9. So I'm going to have step 3 is to take that 9 and plug it back in up here. Now if I add 9 to the left side, I also have to add 9 to the right side to be fair, because math is super duper fair. Now just this piece alone turns into an x plus 3, because the square root of this makes x, the square root of this makes 3. This is positive, so I have a plus there, squared. And then I do the math over here to get equals to 16. Now we taught you this step before as well. We're going to take the square root of both sides to get rid of this squared. So when we square root both sides, we are removing that square. It just turns into an x plus 3. Square root of 16 could be the answers of a positive or a negative 4. So we write down both situations. And then our last step here is to actually solve both of those situations. So if we have an x plus 3 is equal to a positive 4 and an x plus 3 is equal to, oopsies, I went too fast, x plus 3 is equal to that negative 4, we can solve both of those things to get our two answers of x equaling to a 1 and x is equaling to a negative 7. And we did that math to find out our two roots for this quadratic equation. And that tells us very much just where they cross the x-axis. That's why it says x equals. So the same exact kind of math is going to take place on this one. You're going to try this one on your own, and we'll talk about it in class tomorrow. Remember to do all the steps that we did on the previous problem. All right, now on this one, here's a new idea here. Our job is to, before we can do the other things, is we have to get rid of whatever the a is. We cannot have in a completing the square type of a problem, a coefficient in front of our x to the second power. So we are going to divide all pieces by whatever a is, no matter what a is. So we're going to divide everything by a -2. And when we divide everything by a -2, we are left over with an x to the second minus an 18x plus 5 is equal to a -12. And just like last time, we're trying to get rid of this -5 so that we can isolate just this piece right here. So we're going to subtract 5 from both sides. That leaves us with an x squared minus 18x plus whatever that blank spot's going to be, and then equaling to a -17. We are going to calculate c by using the steps that we talked about earlier. We're going to take that -18. We are going to divide it by 2. We're going to get an answer in square. That's steps 1 and steps 2 combined into one thing. And that gets me to a -9 squared. It gets me to an 81. So my step 3 is to take that 81 and plug it back in. So I'm adding 81 to both sides. Oopsie, that was an icky 81. When I do that, just this piece right here is going to turn into my perfect square trinomial. So I know I'm going to have an x because of the first thing. My last one is the square root of that. And my middle number was negative, so it's going to say x minus. Now this math here, we have a -17 and a positive 81. That makes a positive 64, which turns out to be really nice for us when we take the square roots. Now when we square root these things, we get rid of that x minus 9 squared, and we are left with just an x minus 9, equaling to a positive and a -8. Now let's go and pretend that this was not a very nice perfect square number. You would just have a decimal then, and it's okay to have that decimal. And so what we can do now is just solve both those problems, just like we did on the previous one. So we would have an x minus 9 is equal to a positive 8, x minus 9 is equal to a -8. And when we solve, we get x is equal to a 17 by doing that plus 9 to all sides. And x is equal to a positive 1. And those are my two roots for the problem. Now, the only circumstance that we have not yet described to you is what happens if when we get to this step right here, if it were to be a negative number. Because we cannot take a square root of a negative number, this specific situation turns into a no solution. So we got to be aware of when those things happen as well. All right, folks, this is your last question for the notes, and we will go over this one when you come back to class. And this should help us make sense of everything here, folks. All right, this is the Berman Nation. If you have questions, holler at me, and I'm signing off.